All right, time for an example, and it wouldn't be complete without a four-step method, so we have to do a four-step method. Okay, so this example is on is on whether there's a link between obesity and energy spent, and it was done at the Mayo Clinic. And so the data that you will see is actually from the Mayo Clinic that the publisher actually got, and I subsequently am borrowing with permission to give to all of you. So you can read the prompt here as you need to. But the data that we're going to see, it has a group of lean subjects and obese subjects, and it measures the amount of time each day in minutes that each participant spends standing, sitting, or laying down. Okay, and we're just going to look at it standing and sitting, standing and walking. Sorry, that's it. So here we go. Here's the data. So you can see there's lean, and then standing and walking are in the same category. Okay, so we're going to compare the time for these for lean individuals versus obese individuals among this single variable. All right, so let's get started. Okay, so we want to the state. It asks the question: do lean people and obese people differ in the average time they spend standing and walking? So that was my state step. Okay, easy. Moving on. Okay, now my plan step. Of course, this is going to be massive. Okay, and there's a piece that I haven't finished yet because we need to do it together. So you can pause the video, write this all down if you wish, but it's very much following that template. So we talk about the variable, and here we have two variables, right? Because we have two populations. So talk about each of them. I did it all in one line, and I should say which are, that's a typo, are quantitative continuous. And then we can investigate the evidence for the claim using a two-sample t-test, two populations, and the mean. Okay, we need to check the conditions. Okay, this is where we need to have a little discussion. So the observations in each sample are IID. That actually isn't stated in the exercise. I'm assuming that this was a study by the Mayo Clinic, so it probably is satisfied. And generally speaking, if the data that we come into contact with, at least in this course, is going to be an SRS, just so that these conditions work out nicely. Okay, so we're going to kind of punt that one to the side and say, yep, good enough. Number two, is it normally distributed? Again, you can review the prompt, but it doesn't say that. So what am I going to do? I'm going to make a histogram of each data set. So the data corresponding to the people, the lean people. Okay, so just insert a quick little histogram to see what's going on there. Oh, that's pretty normal-ish. And then if I do the same thing for the obese people, okay, now this one we might have to fiddle with it. Let's change number of bins here just to be maybe, nope, I want number of bins. I want to change that to 3, see what it looks like. Maybe 4. Okay, 4 looks better, and so it is normal-ish. So I'm gonna say normality is satisfied. Again, I just see one peak here, and then and so that's enough for us for approximately normal. Okay, so I'm just gonna say here by histogram the samples appear to be approximately normal. And remember that our T procedures are robust enough, so it'll handle these things pretty well. Okay, and then lastly, sigma 1 and sigma 2 are unknown. Yep, and then each sample is 10, so that's at least 5. So yes, the conditions are satisfied. Okay, so now I have to write out my hypotheses. Null and alternative are listed here. Again, mu1 and mu2 are defined above, otherwise I would need to define them here. Okay, and then now we're ready to do the statistics and get the t-test statistic and p-value using Excel. Okay, now I'm going to use Excel, and then I'm going to back up and show you how to do this stuff longhand too. Okay, so using Excel. Okay, I'm going to temporarily delete all this. formally, if you're doing a 4-step method, you should include it in that plan step, but I'm gonna not do that for space purposes. Okay, so now first what I'm gonna do is, just for my own ease, I'm gonna copy and paste the data off to the side here that I want, just so it's in 2 columns. It'll be easier for me to do. Okay, so now really in Excel, all I need to do is go into data, data analysis, and then scroll to the bottom for the t-test, assuming unequal variances. Again, always use unequal. Okay, variable 1 range, select the data, variable 2 range, select the data. If you want, you can enter the hypothesis mean difference, which would be 0, and then output range, just select some cell nearby. Okay, and then you see it's going to automatically give you, these are sample means and sample variance, so mean and variance for lean. I should say this is lean, and then this is the obese population, or the obese sample that we got. Let's see, and then it gave us the degrees of freedom. So rather than doing that long old calculation, it told us the degrees of freedom. And so then it gave us the t statistic, and then there's a couple p-values here, and if you click on them, the first one is for a one-tailed t-test, and then the second one is for a two-tailed t-test. And the reason it's different is because our t-critical value changes depending on where we're at. So you can see our p-value that we want, since we're doing a one-sided test, is 0.0004 or 243. So that's what we're going to use. Okay, so now let's say we don't have all this. So let's say just for fun, I don't know why I don't want maybe say fun, but just for practical purposes, let's say I'm just going to hide this off the screen. Let's say we had this data given to us, right? How do we calculate the test statistic? Okay, that's where we need to go back and use the formula given to us. Okay, so we're going to need to come over here and say, okay, we have, get this. Okay, so our t-test statistic was that x1 bar minus x2 bar, and then over the standard error. And so here I just copied over and then technically the numerator, right, it would have that minus mu1 minus mu2, but that here is 0, so that's why I omitted it. But nevertheless, in the denominator, I did square root. S1 squared is the sample variance, right? So I don't need to worry about square rooting and then squaring again. Just use the variance number, the 11474, and then over 10 for the sample size, okay? And then if we do this with the calculation, we get approximately 4.51, and we can check in Excel. Yep, got the same thing. So you get the same thing either way. It's just you have to be more patient using the numbers by hand, okay? And to save us time and agony, I'm not going to calculate the degrees of freedom, okay? But again, I would just need to follow all that work through and get that. Okay, but then, so I get this, and then I'm just going to note that the p-value here is 0.000243. Okay, so and then also one thing I recommend, just if you don't want to write all this and you have all the data in Excel, just take a screenshot. That's enough here. Okay, if you do a screenshot from Excel, like or maybe a snip if you want to do it that way, just to include the relevant parts, that's perfectly fine as well. All right, and then lastly, we have to conclude, right? So we found the summary statistics, and so this is really, you should, I forgot to do this above here, at least in my work, but I would include that screenshot. You should list the X bars and the sample variances and your sample sizes as well. So you should provide all those statistics. So that's why that screenshot is nice, because it has all that information on there. But so we found everything listed in the solve step. Since p is less than alpha, I defined alpha because it wasn't given. We reject the null hypothesis, and then we have sufficient evidence that the mean time walking standing among lean people is greater than the mean time walking standing among obese people. And keep in mind that based on the sample means, I might have to change that interpretation because Excel automatically uses one direction for the t-test statistic. And then we talk about error, and we're done. Okay, so a nice little example with Mayo Clinic, standing and walking, and a two-sample t-test. Okay, and just keep in mind, in this case, we had the raw data. In other cases, you might not, so you might have to do this calculation here by hand in other cases.